Hi, my name is Travis Austin, and I'll talk to you about the Texas City Refinery explosion. This actually occurred on March 23rd, about 2005 at 1:20 p.m. It killed about 15 people, injured over 180 people, and resulted in $1.5 billion losses. This organization was called BP, and so I want to tell you what happened. So this all started early in the morning, and they had a group of people come down there, and they started filling up the raft from the splitter tower. They were supposed to fill up about 6.5 feet, but they decided to do 9 feet because of the furnace issues. It just wouldn't work correctly. So that's what they did. And later on in the morning, morning shift came in, and they were not briefed. The morning shift was not briefed at all of what's actually going on at night. So they had no idea how much was in the splitter tower. They had no idea what the procedures are. And eventually around 9 a.m., they started to actually start up again. Matter was already overfilled a little bit. So they started the procedure, the ISOM unit, in the morning. They put on the burners, they started filling up the tower that was already basically kind of overfilled, and they did their thing for a little bit. However, they did not open a manual control valve that was supposed to give the raffinite out of the splitter tower, because they were kind of conflicted on the reports, because like I said, they weren't briefed earlier. So around about 12 o'clock or early 12, the raffinite was already about 100 feet in the tower. Grossly overfilled, very dangerously overfilled. And the supervisors that was originally supposed to be there left to a family emergency. So we had one guy there who basically worked his 30th day in a row on a 12-hour shift, completely fatigued. One guy, not to mention he's supposed to be controlling this ISOM unit, but in addition to 3 other units too. And so it was actually a big issue. So he wasn't putting all attention matter he should have been. Around about 1 o'clock, high-level alarms went off in the tower, and they were very confused with what's going on. So they decided to turn off some furnaces, finally opened the manual control valve, which was closed for like 5 hours. That's why it's called the overfilling. And what this really caused, because they went to an heat exchanger, is to increase the temperature to 141 degrees Fahrenheit. This caused the liquid to boil. And eventually it overfilled the splitter tower, and it went into 3 pressure relief valves that immediately opened, because this is supposed to be a vapor, right? And it's all liquid. And it came in and hit into a 1950s blowdown drum. And it basically filled it up, and there was an alarm there, and it did not go off. And it went all the way to the top, and it spread out like a geyser. Eventually it spread up and went up like a geyser, and it formed a very flammable vapor cloud that was eventually ignited by a local, or really close, I guess you say, a pickup truck. And it resulted, and after that, exploded, and it killed about 15 people and injured 180 people. So that what's happened, but I want to tell you design issues, because a lot of design issues here. The first issue was very bad maintenance. Like once BP merged with Amoco, they cut actually maintenance by 25%. And they just didn't really care too much about what's going on with their system, especially the ISOM unit. Not to mention the trailers that was very close by that resulted in 15 deaths and 180 injured, was basically location of the trailers, as it was way, way too close to the ISOM unit. Way too close. It was like literally right there. If they had a minimum distance set, they could actually save some lives and save the injuries. Not to mention, when I talk about maintenance, I talk about cleaning too. It wasn't even cleaned. So they actually had an indicator of how much liquid was in it by just looking at it, but unfortunately, since it wasn't cleaned, it was really dirty, they could not tell. And so those were little major design issues that they had. Regarding process issues, and actually this is actually what I have in the computer scene in the control room. So we had the level indicator, like I said. And they were, like I said, deviated from procedures, went up to 9 feet, and they really didn't know how it was overfilled, and that was an issue. The level indicator only told that it can only fill up to 9 feet, right? Matter this tower was over like 100 feet tall, right? So they didn't know, and that was a big process design issue right there. If they knew how much was in there at all times, so I mentioned the control room, the material balances went on the same page as the ISOM unit, so they had no idea how much is going in, how much is coming out. Not to mention the pressure relief valves was completely out of date. The high-level alarms were not working. They put a lot of maintenance stuff in there, like work orders for it, but they always get closed. They would say it's done, but it's not done, because they just didn't really want to do it, because they didn't feel like safety was very important to them. And that's pretty much my next section about management issues, because there's quite a lot of this issue, a lot of these things. So lack of effective communication, that for sure happened, especially when after the non-operators left and the morning armors came in, no one was briefed about anything. There was actually something in the logbook, but it didn't really say anything about the procedures or what happened at all. Completely just out of the blue. Lack of leadership. The supervisor came in an hour late, so obviously he wasn't briefed by anybody. Came in an hour late and left like 3 hours later, about 11, to a family emergency, was not replaced. And that is completely against BP policy, but they did it anyway, and they didn't know what to do. And not to mention, regarding procedures in general, is that they had procedures written, right, by BP, but they never followed them at all. And like if they're out of date, they need to update them. They can just have out-of-date procedures and not follow them, not enforced, because it's caused problems with the first part, which is supposed to be, the tower was supposed to fill 6.5 feet, and they filled with 9 feet because they deviated from procedures because they thought it would break up the furnace. Well, they need to update that, and these things weren't enforced at all. Fatigue, like I said, there's a guy that came in for 30 days straight, basically working 12-hour shifts. I mean, that guy's tired, honestly. Not to mention they only had one operator in the room when there should have been 2, but they had 1 instead. Regarding training too, they didn't like people in these situations, like I said, were confused when these alarms were coming off because they weren't trained for this. The training in the management was basically just by computer, not by actual face-to-face, like face-to-face in training. It was basically just do a computer, do some tests, and you're good to go. We're just gonna throw it in the field. Wasn't very good at all. Not to mention this training was cut with BP, so there's a lot of issues with that. So we're going recommendations here on what they could do better. With design, they did actually enact, OSHA did, a basically minimum distances of the trailers to a very dangerous unit like the ISOM unit. That's a big recommendation. The second recommendation is to actually update their systems, not have a 1950s blow jump, but instead of flare, instead to burn off anything dangerous. That's what they could have done too. Regarding the process, they could have, like I said, a leveling indicator. Why was it going to 9 feet? Can it be all the way to the tower? Can you have the control room and put the material balance right on top where the ISOM unit was? That's a big issue. Update the pressure relief valves. In addition, provide interlocks of the actually ref on splitter tower when it actually reaches a certain feet in liquid, that it just immediately stops all flow and is just like hello. Not to mention the high level alarms. I mean, they were there. They weren't effective though because no one had worked on them. I mean, there was no budget for it. Management issues. People need to come on time. Obviously, there's going to be more effective leadership in there. When it comes to training, there needs to be more face-to-face contact and more basically like situations that happen this and train for that. You know, like have more than one operator there, 2 operators instead of 1, actually working, maybe even 3. You know, that's all good. And just overall, they just need to just be better at management, design, and process. They were decided to save money because that's what they cared about. They had like 7 different business leaders coming in, and they didn't really care too much about safety because they thought it wouldn't happen my time. It was very rare and wasn't my concern. They were just based on how much money they made. And that is what happened, basically, the Texas City Refinery explosion. And it's, you know, very, very sad. And all these could have been saved if people actually were effective, if things were updated, if these were maintained, if they had a good process equipment, and it had good leadership. Unfortunately, this was not the case. It resulted in 15 deaths and over 180 injured. And thank you so much. Like I said, I'm Travis, and thank you again.